Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, so today in this video we are going to look into, discuss a solution for Pspm questions for topic semester 1, topic 9, differentiation. Okay, so I prepared 6 questions as you see on the screen here now, and this is a question that you can straightly refer to the collection of past year questions from your tutorial book, and without wasting so much time. And these are the questions that we're going to discuss for this 1 hour. Question number 4, number 9, 11, 17, 21, and 32. Okay, so given here y equal to 4x plus 1 multiplied with e to the power of x. So we're going to find out dy dx and second derivative of y respect to the x, and hence evaluate second derivative of y respect to the x when x equal to 0. So we're going to derive or differentiate for the first time here. Okay, so then dy dx equal to, okay, here we divide into 2 parts. First is this one we define as a u, and this is our v. So y equal to u dot v, then y prime equal to derive for the first, we call the first u here, and give you u prime multiplied with v plus with, okay, just now we derived the u, then you get u prime multiplied with v. Now it's time for us to copy out the u and derive or differentiate v, it gives you v prime. Okay, so this is the idea here now. So for the first part here, u equal to 4x plus 1 and v equal to e to the power of x. So then u prime equal to differentiate 4x plus 1, yes, it gives you 4, and v prime differentiate e power of x, e to the power of x. Okay. Okay, so y equal to 4x plus 1 in bracket multiplied e to the power of x. So now let's substitute u prime, u prime, v prime into this formula here. So u prime dot v, u prime, which is 4 multiplied with v, e to the power of x. 4 e to the power of x plus with u here, u multiplied with v prime, u 4x plus 1 multiplied with v prime, e to the power of x. Let's simplify this. 4 e to the power of x, and then 4x multiplied with e power of x, 4x multiplied with e to the power of x, and then 1 multiplied with e power of x, e to the power of x. Okay. 4 e to the power of x plus e to the power of x is just like 4 plus 1 equal to 5 e to the power of x plus 4x e to the power of x. Factorize, take out e to the power of x. Then we got 5 plus 4x. Okay, so this is our dy dx. Now we can differentiate, derive again for the second time, second derivative of y respect to the x. So right now this is now our u and this is our v. The first derivative, okay, from y equal to 4x plus 1 multiplied with e to the power of x, then we define this as a u and this one as a v. Now we get the second, we call dy dx, as you see on the screen here now, okay, here. So we define this as a u or v, or the other way around. It's all up to you then. Okay. So let's say if I put this u, okay, you can define ex as a u or 5 plus 4x as a u. It's all up to you then. So if I define this as a u, and this is our v, okay, u equal to 5 plus 4x, v equal to e to the power of x. Then u prime equal to, differentiate 5 plus 4x, again 4, and v prime equal to e to the power of x. again, using this formula, u prime dot v plus uv prime. So u prime first here is 4 multiplied with v e to the power of x plus with u 5 plus 4x, and v prime again derive e power of x, yet still gives you same e to the power of x. Okay, in fact, we call expand and simplify this 4 e to the power of x plus 5 multiplied with e to the power of x, and then 4x multiplied with x has 4x e to the power of x. So then 4 plus 5 equal to 9 e to the power of x plus 4x e to the power of x. Factorize, take out of e to the power of x, and we get 9 plus 4x. There you go. Okay, so the question wants us to use the second derivative, find the value of so now, hence evaluate second derivative with respect to the x, as we seen here, which we get here now, at x equal to 0. So when x equal to 0, so then second derivative of y respect to the x, when x equal to 0 equal to e to the power of 0 multiplied with 9 plus 4 times 0. So e power of 0 equal to 1. 9 plus 4 times x. When x equal to 0, this is 0. So 9 plus 0 equal to 9 multiplied with 1 equal to 9. Okay. That's it. Okay. The first question, which I select question number 4. Then next, given that y equal to 1 over square root of 2x plus 1 by using the first principle of derivative. Okay, class, for this question, you cannot simply solve question number 9a1 by just simply derive it in an easy way. Okay, so we must use the first principle method. Okay. The idea I'm going to give you here now is y equal to 1 over square root of 2x plus 1. And bring this above here, you can come up with, or this one we can also define as 2x plus 1 to the power of 1 over 2. Okay, so bring this above here, you come up with 2x plus 1 to the power of negative 1 over 2. Okay, so y prime or dy dx, negative half, bring it in front here, negative 1 over 2, then 2x plus 1, negative half minus 1, negative 3 over 2. And that's not all. We multiply with the derivative of 2x plus 1. Derive 2x plus 1? Yes, multiply with 2. So 2 divided by 2, we got negative here, negative 1, and this one here, it is negative 1 over 2x plus 1 to the power of 3 over 2. Okay, class, we cannot simply derive or differentiate like this, okay, for this question. But then, we derive, we differentiate the function of y to get as this one here, just as a reference, okay, as a reference, from this one here, y prime equal to the limit of h approaching to 0, okay, limit of h approaching to 0, fx plus h minus fx divided by h. So this is the formula of derivative using the first principle. Okay. 1 over square root of 2x plus 1 plus 1 x plus h plus 1 minus, fx plus h minus fx, 1 over square root of 2x plus 1, and everything divided by, and everything divided by h. Okay, class, if we straightly substitute h0 here, so any values divided by 0 is undefined, meaning it's meaningless. Okay, we are not going to do that here. So the things that we're going to do here now is we are going to multiply with a conjugate of this. Before that, okay, limit h approaching to 0, let's simplify everything that inside this big bracket. Okay, nope. I think that I'm going to recall. So then I'm going to make write down here now y prime equal to negative 1 over 2x plus 1 to the power of negative 3 over 2 multiplied with 2 here, and it is negative 1 over 2x plus 1 to the power of 3 over 2. Okay. I need a space here. Okay, so now multiply 1 square root of 2x plus h plus 1, okay, minus 1 over square root of 2x plus 1, okay, multiplied with a conjugate of this. Okay, so this is minus, the minus that we call minus, that is plus here. So, and also here, 1 divided by square root of 2x plus h plus 1. Okay, square root of 2x plus 1, including here, sorry. Plus with 1 over square root of 2x plus 1. Okay, now equal to limit h approaching to 0. Okay, so this one multiplied with this. So square root multiplied with the square root, the same function inside, it gives you 1 divided by 2x plus h plus 1. Okay, and then this multiplied with this. Plus with 1 over square root of 2x plus h plus 1, and then this one here, 1 over square root of 2x plus 1. Okay, so the first part for this one here is this between this multiplied with this one here. So square root of 2x plus h plus 1 and 1 over square root of 2x plus h plus 1. So we cancel or eliminate the square root sign here, and then now between this and this, and we get this one here. Next, between this and this one here, minus 1 over square root of 2x plus h plus 1 multiplied with 1 over square root of 2x plus 1. And then next, here, it is, okay, negative multiplied with positive. Negative 1 over square root of 2x plus 1 with square root of 2x plus 1, it gives you 2x plus 1. Okay, and everything here. Okay, I'm sorry. It's not very nice, not straight here then. Okay. Okay, and everything divided by h and we multiply with this. Okay, 1 over square root of 2x plus h plus 1 plus with 1 over square root of 2x plus 1. Okay, so look at these two here now, this and this. Okay, actually that positive somewhere around here. So it what we call cancelling between these two, because these two are equal. The only different thing here now here is this is positive and this negative. So it means that it deduct or subtract with itself. Okay, so that limit h approaching to 0. Okay, this one here now, 1 over 2x plus h plus 1. Here, this one here, and minus this, minus 1 over 2x plus 1. Okay, this, let's say if h I bring it above here, okay, is everything divided by h and 1 over square root of 2x plus h plus 1, and then plus with this one here, 1 over square root of 2x plus 1. Okay, if I bring h above here, bring this h, come up with 1 over h. And also here, bring this above here, you're going to come up with okay class, okay, so I changed my plan here. Okay. Okay, let's say if I simplify this one minus this and simplify between this and this. Okay, so I'm going to get limit h approaching to 0. Okay, multiply between these two. 2 times square root of x plus h plus 1 multiply with 2x plus 1. So we also call it as a cross multiply between, okay, these 2x plus 1 multiply with 1 here, and also this multiply with this one here. So it's going to give you 2x plus 1 multiply with 1, 2x plus 1 minus, okay, 1 multiply with this, 2x plus 2h plus 1, and everything divided by h. Okay, multiply, okay, simplify between these two. So cross multiply 1 with this, square root of 2x plus 1, and plus with 1 multiply with this one here, plus with square root of 2x plus h plus 1 divided by, okay, multiply multiply between this denominator and this one here, it can give you square root of 2x plus h plus 1. And then multiply with square root of 2x plus 1. Okay. Now, if I open up this bracket here, it's gonna give us 2x plus 1 minus 2x minus 2h minus 1 minus 2x minus 2h minus 1 and divide by h, square root of 2x plus 1, all the denominator here, plus with square root of 2x plus h plus 1, and everything divided by square root of 2x plus 1 multiplied with square root of 2x plus h plus 1. Okay, so 2x minus 2x, 1 minus 1. So on the top here, it's only left negative 2h divided by h and everything inside the bracket here. So class, I forgot something, should be limit h approaching to 0. Okay, so 2x minus 2x, 1 minus 1, and left here is negative 2h divided by h, everything here. So let's cancel between this h and h. Limit h approaching to 0. So what left here now? Negative 2. Okay, negative 2 divided by, and now it's time for us to substitute the value of h approaching to 0 here. Okay, so let's substitute h with 0. Here is also h equal to 0. So then 2x plus 1 plus square root of 2x plus 1. So then it come out with 2 square root of 2x plus 1 divide by, so square root of 2x plus 1 multiply with square root of 2x, h equal to 0 then here, so multiply with square root of 2x plus 1, it give you 2x plus 1. Okay, so for this denominator is also a fraction. So if we bring above here, class, we already substitute the value of h equal to 0 and 0, so we don't need any more limit of h equal to 0. Okay, so then negative 2. Okay, let's imagine that this we bring above here, so it's then position upside down. So it give you 2x plus 1 divided by 2 square root of 2x plus 1. So 2 divided by 2. Okay, and then negative. Look at this one again. Negative. So we got negative here. 2x plus 1, which means that this is 2x plus 1 power of 1. And this is square root of 2x plus 1. We call denominator here. Okay, so we bring this 2x plus 1 power of 1 below to join up this one here. It come out with negative 1 over 2x plus 1 to the power of 3 over 2. Okay, so equal, similar as this one here. Okay, then next is find second derivative of y respect to the x. So I'm going to clear all this. Okay, I'm sorry then. So I'm going to clear everything here. Okay, never mind. Now, okay, this is our, so we have proved that we call the first derivative or dy dx using the first principle is dy dx equal to negative 1 over this one here is just like negative 2x plus 1 to the power of negative 3 over 2. So find second derivative, we don't need to use the first principle anymore. We can strictly find the second derivative of y respect to the x. Okay, so negative 3 over 2 multiplied with negative 1 equal to 3 over 2. Then 2x plus 1. Negative 3 over 2 minus 1, or negative 3 over 2 minus 2 over 2, negative 5 over 2. And derivative of 2x plus 1, 2x, differentiate 2x plus 1, then multiply with 2. So again here, it is 2x plus 1 to the power of negative 5 over 2. Okay, so this is a solution for question number 9. Okay, now, given that y equal to x e to the power of negative 5x, find y prime and y double prime. Okay, so and then show that we call this one here equal to 0. So that u equal to x and v equal to e to the power of negative 5x. So that u prime differentiate x equal to 1 and v prime differentiate this negative 5 e to the power of negative 5x. So that y prime or dy dx equal to u prime multiplied with v. So u prime is 1 multiplied with e power of negative 5x plus with u v prime, where x multiplied with negative 5 e power of negative 5x. Okay, so negative with positive, negative e power of 5x minus x e to the power of, okay, 5 here. Okay, 5x e power of negative 5x. So factorize e power of 5x and 1 minus 5x. Okay, so this is y prime. And then y double prime. Okay, now let u equal to 1 minus 5x and v equal to e power of negative 5x. So then u prime equal to differentiate 1 minus 5x, yes, negative 5, and v prime negative 5 e to the power of negative 5x. Okay, so then u prime multiplied with v, negative 5 e power of negative 5x plus with u v prime 1 minus 5x, and v prime is negative 5 e power of negative 5x. Okay, so simplify this, expand negative 5 e power of negative 5x, 1 multiplied with this minus 5 e power of negative 5x, and negative become positive, 5 with 5, 25x e power of negative 5x. Okay, so now negative 5 e power of negative 5x minus 5 e power of negative 5x, negative 10 e power of negative 5x plus 25x e power of negative 5x. Okay, so this one here, e power of negative 5x between 10 and 25, let's divide by 5, it gives you 5. Okay, so negative 2 plus 5x. Negative 5x, negative 5 times negative 2, negative 10 e power of negative 5x, and 5 with 5, 25x e power of negative 5x. Okay. So now, so let's arrange all this in this form. Y double prime is 5 e power of negative 5x, then negative 2 plus 5x plus 10y, y equal to x e power of negative 5x, and plus 25y, okay, wait a minute, y prime, y double prime, 10y prime, sorry. Okay, y double prime, 5e power of negative 5x, then negative 2 plus 5x, then plus 10 y prime here, 10 and y prime equal to e power of negative 5x, and 1 minus 5x, and plus with 25y, y equal to x e power of negative 5x. Okay, so let's expand this again. So for this one here, I'm going to use this negative 10 e power of negative 5x plus 25 x e power of negative 5x. Okay, 10 multiplied with this one here, y prime. Okay, if I use this line here multiplied with 10, so we get plus 10 e power of negative 5x plus with 10 multiplied with this minus 50 x e power of negative 5x, and then 25 multiplied with this one here plus with 25 x e power of negative 5x. Okay, so 25x e power of negative 5x plus 25x e power of negative 5x. Before that, negative 10 e power 5x plus 10 e power 5x, clear. And then 25 plus 25, 50 x e power of negative 5x minus 50 x e power of negative 5x, and equal to 0. Get it? Okay. Now, question B. Y equal to natural log of 3 minus 2x divided by 5x minus 1. Okay, in this, for differentiate of log function, we're going to use the rules of log with log A divided by B divided by log A minus log B. So, make an adjustment for this question here. It's come out with ln 3 minus 2x minus natural log of 5x minus 1. Okay, so then y prime equal to, differentiate ln, automatically it gives you 1 over. So then 3 minus 2x. And that's not all. Multiply with derivative of 3 minus 2x, negative 2. Minus, okay, differentiate ln, automatically 1 over 5x minus 1. Multiply with differentiate 5x minus 1, yes, 5. So then we got negative 2 divided by 3 minus 2x minus 5 divided by 5x minus 1. There you go. Okay, class, if you refer to the final answers given behind, then the final answer is given, then we are going to simplify these two fractions into one, meaning negative 2 multiplied with 5x minus 1. Negative 2 times 5, negative 10x. Okay, negative 10x. Negative 2 times negative 1, positive 2. Negative 5 times 3, negative 15. Negative 5 times negative 2x plus 10x divided by, okay, 3 minus 2x and then 5x minus 1. Negative 10 plus 10 equal to 0. Then 2 minus 15 equal to negative 13 divided by, yes, 3 minus 2x and 5x minus 1. There you go. Okay. So then, clear all this. Okay. Y equal to tangent cube 4x. Okay, class. In this kind of question, we are going to differentiate one by one. Okay. So the first thing that we differentiate is the power of this trigonometric function. Okay. 3 tangent square 4x. So the power, which we call this our priority for number 1. Then second part is we're going to differentiate the tangent. And finally, we differentiate the function inside. So then y prime equal to 3 tangent square 4x. Okay, that is the first one. Multiply with, differentiate the tangent, secant square. Differentiate tangent, secant square, 4x. And differentiate 4x, it gives you 4. So this 4 simplified, multiplied with 3 equal to 12 tangent square 4x and secant square 4x. Okay, now substitute x with pi over 16 and also here. So then y prime when x equal to pi over 16 equal to 12 tangent square 4x equal to pi over 16 and secant square 4 times pi over 16. So 4, 16, 4 here, and 4 is 16, 4 here. Okay, so you substitute and we call substitute all the functions with we call pi over 4 and pi over 4. Pi over 4 is 45. So tangent square 45 and secant square 45. Substitute into what we call the value into your calculator, and finally it's gonna give you K 24. Okay, find out yourself. You use your calculator to finalize the answer here for question number 11. Okay, now find dy dx for each of these. So for A, y equal to sine natural log of 3x. So then dy dx equal to differentiate 1 by 1 from outside to inside. From outside to inside. So first we differentiate sine, it gives you cos natural log of 3x. Multiply with, now derive or differentiate ln 1 over 3x. Multiply with, differentiate 3x, it gives you 3. So 3 divided by 3 here, so it gives you cos natural log of 3x divided by x. now question B. Okay, so then y equal to x divided by x cubed plus 1 plus with e power of 2x multiplied with tangent x. Okay, there are two separate functions here, okay, between this and this. And for this one here, okay, for this is actually they derive a function of fraction here. So we define this as a u and v. Derivative of this, we come up with u prime dot v minus u v prime divided by v squared. And for this one here now, between u and v here, using chain rule, we come up with u prime v plus u v prime. Okay. So the first one here, let u equal to an x and v equal to x cubed plus 1. So then u prime equal to 1 and v prime equal to 3x squared. Okay, this is for here. And next one here, u equal to e power of 2x and v equal to tangent x. So u prime equal to 2e power of 2x and v prime equal to the differentiate tangent secant square x. Okay, so now y prime equal to, or dy dx, okay, dy dx equal to, okay, u prime dot v minus u v prime divided by v square. U prime 1 multiplied with v, so 1 multiplied with x cubed plus 1 minus u and v prime 3x squared divided by v squared, which is x cubed plus 1 squared. Okay, so this derivative of this fraction here, plus with this one using chain rule, plus with now, okay, u prime dot v 2e power of 2x tangent x plus u, okay, and v prime secant square e power of 2x secant square x. Okay, so then x cubed plus 1 x cubed plus 1 minus 3x cubed divided by x cubed plus 1 squared, okay, plus with this one here, e power of 2x and e power of 2x, so then e power of 2x, then 2 tangent x plus secant square x. Okay, so x cubed minus 3x cubed, so 1 minus 2x cubed divided by x cubed plus 1 squared plus with e power of 2x, 2 tangent x plus secant square x. There you go. Okay, question 17, 21 and 32. Okay. Okay, now question of parametric equation. They give given here x equal to negative 9 sine cube t and y equal to 3 minus 3 cos cube t. Okay, show that dy dx is given here and then solve dy dx equal to 0 for t in between 0 until pi. Okay, now to find dy dx in this parametric equation, x with t, y with the parameter of t here, then we come up with dy dx. Okay, but then for this one here, dy dt dt dx. Okay, so we can differentiate this one by one. Dx dt equal to negative 9. Okay, I think I need to bring this a little bit down here. Okay, never mind. Okay, differentiate the function. We call the power of 3 here 3 sine square t. And then, okay, just now we differentiate the power of 3 sine square t. And now differentiate sine, it gives you cos t. And then differentiate t equal to 1. Okay, simplify this. Multiply with 1. Negative 9 times 3, negative 27 sine square t cos t. Okay. Y equal to 3 minus 3 cos cube t. So then dy dt equal to, differentiate 3 equal to 0, then negative 3 here, negative 3, differentiate the power of 3 here, 3 cos square t. Okay, we complete differentiate the power of this function first, then differentiate this, we call the trigonometric function cos, it gives you negative sine t, and multiply, differentiate the power, the parametric of 3t here, it gives you 1. Okay, so negative 3 times 3 equal to negative 9. Negative with negative, come out with positive. Okay, cos square t sine t. Okay, so now dy dx equal to dy dt multiply with dt dx. So dy dt is all here, 9 cos square t and then sine t multiply with, okay, dt dx, but what we have here right now is dx dt, so we need to change the position upside down here, or come out with 1 over negative 27 sine square t and then cos t. Okay, so now this one, 9 cos square t sine t multiplied with 1 over negative 27. Okay, 9 divided by 27, negative here, give you 3. Okay, cos square, okay, 1 over cos with this one here, cos, sine with 1 over sine here. So, it is 1, okay, cos t, and then negative 1 over 3 cos t, and then sine t. So negative 1 over 3, as given here, negative 1 over 3 cotangent cos over sine is cotangent t. There you go. Okay, and the question wants us to find this. Solve this one, dy dx equal to 0. Negative 1 over 3 cotangent t equal to 0. Okay, multiply with 3 here, still cotangent t equal to 0, and then cotangent is 1 over tangent t equal to 0, and tangent t is also equal to 0, then okay, so then t equal to arctangent of 0 and equal to 0. Okay, to find the value of t between 0 until pi. Okay, So for this one here, tangent 0 equal to 0 degree and 180 degree. Okay, use the calculator to get the answer then. Okay, now show that second derivative of this. Okay, now I'm going to clear all this. Okay, we like to find second derivative of y respect to the x. Okay, in this case, okay, class, from the parametric equation of x with the parameter of t, y with the parameter of t, then we find dx dt, dy dt, and to find the dy dx, we come up with dy dt multiplied with dt dx. Okay, so now the same concept that we're going to implement here, d dt multiplied with dt dx. Okay, so just now we substitute with y, dy dt. So it's time now for this one here with dy dx, d dy dx respect to the t multiplied with dt dx. So in this case, we just need to find this one here. Okay, we're going to find out what is the equation of this. But then for dt dx, we can just simply use the dx dt that we found earlier here. We're going to recall dt dx is 1 over negative 3 and 1 over negative 27 sine squared t cos t. We're going to substitute this again here. Okay, meaning we don't need to generate the x dt for the second time. We can just simply use the one that we get earlier. But for this one here, we need to generate. So now let me find out d dt of dy dx. Okay, meaning we differentiate this. Differentiate dy dx here. Differentiate dy dx respect to the parameter of t, which is negative 1 over 3. Differentiate cotangent, is it negative cosecant square? Okay, class, sorry. I need to find what we call the derivative of cotangent first. Okay, so negative 1 over 3, then differentiate cotangent, negative cosecant square t, and then differentiate t equal to 1. Okay, so negative become positive, 1 over 3 cosecant square t. Okay, so now to find the second derivative with respect to the x, this one we already find it here. Okay, which is negative 1 over 3 cosecant square t, and then dt dx, let's look at this one here, dx dt, so dt dx is 1 over negative 27 sine square t and cos t. Okay, negative 1 over 3. Cosecant is 1 over sine. So 1 over sine square t, and then 1 over negative 27 sine cube t and cos t. Okay, so the final answer is negative 1 divided by 81. Okay, we got negative 1 here. So negative 1 divided by, okay, bring up the negative. Okay, this is not negative here. Okay, 1 over 3. This negative, bring up negative here. Negative 1 divided by 27 times 3 81 sine square t multiplied with sine square t, sine square t multiplied with sine square t, sine power of 4t, and then cos t. There you go. Okay, so that's it. And the last example, final example here, find the gradient of the curve of this at the point of x equal to 0. So class, just imagine that this is any curve, okay, any kind of curve. Okay, find the gradient, meaning we are going to find the dy dx gradient at this point, which means that we are going to find that dy dx and so on. So to find the gradient, meaning we're going to find that dy dx for this function, okay, and this is considered as an implicit function. So differentiate respect to the x of the cos 4xy equal to derive respect to the x of tangent xy squared minus derivative of y we call 3y respect to the x. Okay. So let's derive this one by one. Differentiate the cos, it gives you negative sine 4xy multiplied with, and now we differentiate 4x first. Differentiate 4x, it gives you 4 multiplied with y plus with, now just now we differentiate 4x, is now we call write down 4x and turn for y, turn of y now. Differentiate of y equal to 1, but then since that because we differentiate respect to the x, so differentiate y equal to 1 multiply with dy dx. Okay, equal to differentiate of tangent secant square xy square multiplied with differentiate of x equal to 1 multiplied with y square plus with, just now we differentiate x, and next we differentiate y square, come out with 2y, and because we differentiate y respect to the x, then we come out with dy dx, and this one here minus 3 dy dx. Okay, let's expand and simplify first. Negative sine 4xy multiplied with 4y, we get 4y minus here negative 4y sine 4xy, and then negative with positive, negative 4x, and then sine 4xy, 4x sine 4xy dy dx. Okay, y squared multiplied with secant square xy square, so y square secant square xy squared, and then this one here multiplied with this one x to y plus 2xy and secant square xy squared dy dx, and minus 3 dy dx. Okay, so the term with dy dx, we put them all together on left side, and the one without dy dx we put on the other side. So this one here, and then negative 3 bring to the side become positive, and this one positive bring it become negative, so then negative 4x sine 4xy, okay, this one here, and then this positive bring it become negative, minus 2xy secant square xy squared, and plus 3 factorize all them together, multiply with dy dx equal to, okay, bring this to the other side, join this one here. So we got y squared secant square xy squared, and then plus with 4y sine 4xy. Okay, so now dy dx equal to this one here, y squared secant square xy square plus with 4y sine 4xy, and everything divided by all this on this bracket here, negative 4x sine 4xy minus 2xy secant square xy squared plus 3. Okay, so this is our dy dx, quite long. Okay, and find gradient at the point of where x equal to 0. So when x equal to 0, substitute. We got x here, 4xy, we got x here, and we got x here, and 3. Okay, so according to the final answers given, then it is 1 over 27. So you get x here, substitute x with a 0 here, x with a 0, x with a 0, x 0, 0, and try if you can get it as a given, final answers given that 32 is 1 over 27. Okay, that's all for today. I do hope that this video helps you with your studies and help you to continue with your tutorial and past year questions and get ready, prepared for the final examination. That's all. Thank you very much. Till we meet again. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.